right? For this class, we're going to do area and volume now, which is very simple. We're in the week 3. We're in week 3, so we'll see if we can complete this. All right, so we should formulate a simple working definition of the term area. Formulate a simple working definition of the term volume. Use appropriate units of area and volume, right? Calculate the area of a regular shape, area of irregular shape, and the volume. So we'll try and complete, hopefully, we'll try and complete this today, this area, or this section here, right? That's what we want to try and complete today, this section, right? Um, any questions before we begin? All right, so I'll take that.
Sir,
Yeah, question.
are you going to send this in Google Classroom?
Yeah, everything we're posting on Google Classroom. All right. So we'll go down to area. So area is essentially defined as the amount of space that is occupied by a 2D shape, right? This is very important. 2D, two-dimensional shape on a flat surface, right? This is also very important. Flat surface. So we have some 2D shapes over here. We have circle, we have a triangle. These are 2D shapes. And we have our circle and we have a square, right? These are 2D shapes. And in order for us to find the amount of spaces occupied, we need to calculate the areas, right? All right, so the next point is that area is measured in meters squared, right? Meters squared. This is important. Area is measured in meters squared, right? No, volume, on the other hand, is the amount of space that is occupied by a 3D shape. Are you hearing me more clearly? For the person who was having trouble.
Yes, sir.
All right, wonderful. Um,
Sir,
go ahead.
sir, where is the area and something screen?
Okay.
Sir, you just share that screen showing the area and something else. I was writing and it disappeared.
Oh, as I said, I already said
There's no need to write.
Right. There is no need to write. If you want to write, you can do it after the class. But we don't have much time for you to sit down and write. We want to cover as much as possible. We only have 30 minutes in the session, and we have
Okay.
already 30 minutes have gone. So we're a little short on time for you to be writing. So you don't need to waste time writing. All this will be posted, right? So I'm begging you now to just pay attention. That's all I need to do right now, right? So moving on to volume is defined as the amount of space that is occupied by a 3D shape, right? 3D. So area is for 2D, right? But volume, right? Volume is for a 3D shape, right? And this essentially determines the amount of water that can hold in that object. So a volume of, say, a cup, right? You have a cup here, this cup right here. The volume of this cup would be the amount of water that can hold in this cup, right? Very simple. Although when I'm asking you for the definition of a volume or area, I don't want you, right? Somebody's getting kicked out. Wonder why. Well, I don't want you to come up with any random definition of volume or any definition from Google. I don't want you to copy and paste. I don't want you to copy and paste anything from Google. I want you to be able to understand this, right? Volume, 2D shape, area, but area, 2D shape, volume, 3D shape, right? And of course, volume is measured in meter cube. Volume is measured in meters cube, right? Very important. All right, so are we good so far? We're
Yes,
good?
sir.
All right. All right, no. So we're moving on. Oh, before we move on, what are some applications of area? Like what would you need the area for? What can you think of? Like when we are purchasing land, right? When we're purchasing land, we need to know the area of that land, right?
Yes, sir.
Yeah. So the more land we
Yes,
have,
sir.
the more land we have, or the more area of land we have, right? We have to pay more. So that's one important application of area, right? And of course, an application of volume is, as you said, determining the amount of water or liquid that can hold in a particular object, right?
So
Go ahead.
sir, air have to do with like land, and then some of the volume have to do with like
What am I to do with what?
air have to do with like land and this and that, and the volume have to do with like liquid.
Yeah, yeah, essentially, right? That's just an example, right? It's not so we can move on. I'm just add this person here. All right, so let's move on. I'm going to have to mute his mic. All right. Just excuse me. All right. So for calculating the area of a triangle, right? When we will highlight some important shapes, you won't need to know like the area of, for example, a sector or an ellipse or a trapezoid, right? Right. You just need to like focus on the ones that you are you already acquainted with. So for example, our triangle here, we need to know how to calculate the area of a triangle. Sashana, could you kindly mute the mic for a second? Thank you. I'm hearing some noise in the background. Right. So
Sir, I cannot hear what you're saying. There's a lot of noise in the background.
Sashana. All right. Miss Blake. All right. Thank you. Yeah. So we were saying that when we want to calculate the area of shapes that we already are acquainted with, right? For example, from mathematics, we're acquainted with the triangle, right? We're acquainted with the square, rectangle, circle, and of course parallelogram, right? So these are ones that we're acquainted with already. For physics, you won't need to necessarily know how to calculate the area of a trapezoid or a sector or ellipse, right? So you can just omit these for now, right? These are mostly mathematics, right? You can omit these for now. No, you can omit them, right? But you need to be able to calculate the area of the triangle. You need to be able to calculate the area of a rectangle. You need to be able to calculate the area of of our circle, and we need to be able to calculate the area of parallelogram and the square, right? So, what is the formula for calculating the area of a triangle?
Sir, the base times I times the
Right?
I times B times B.
Right? So it's half
The base times height.
Base times height.
Chuck, remember.
Yeah, so it's right here. Half base times height. So for example, our,
Oh, yes, sir.
yeah, so let's say our, let's say our base is 2 meters. Our base is 2 meters, right? B equal 2 meters. Let's say our base is 2 meters and our height is also 2 meters. What would be the area of that triangle? All right, so area of triangle, area would be
Four,
equal to, let's work it out together. So you have half times, what's the base? 2, right? Base is
So
2,
the base is 2.
right? Base is 2, and the height is also 2,
2.
right? So that would be 2 times 2 will be 4, right?
Yes,
What would our
sir.
area be? 4 divided by 2, right?
Sir, area would be 8, sir.
No, because
So the area would be 2.
yeah, the area will be 2. And 2 what? 2 bananas,
2 meters.
right?
2.5 meters.
2 meters
And 2 meters
squared.
would be.
2 meters squared, right?
Yes, sir.
Right, because the unit for area is 2. Is meters squared. Sorry, the unit for area is meters squared. All right. So we know the formulas for these, right? We know the formulas for these. Now we want to say determine the area of this guy. We don't have this we don't have the formula for this. So after we finish this, we can end class for today, right? So
Yes, sir.
to calculate, this is an irregular shaped object, right? And we don't have the formula for this. So to calculate the area of irregular shapes, right, we must simply divide the irregular shape into regular shapes. So regular shapes meaning these shapes around here, our triangle, our rectangle, our square, and our parallelogram and circle, right? If we can somehow divide them, then we'll be able to find the area of the irregular shaped object,
Area.
right? So let's divide this irregular shape now into, first we must divide it into regular shapes. So let's divide this. We have figure 1. What is figure 1? What is figure 1 here?
4, sir.
No, I mean, like, what is the figure? What is it? A circle,
A triangle.
right? So figure 1 is a triangle. So let's put that down. Figure 1 triangle. And what is our formula for triangle again?
Base times height.
So that is half, right?
Yes, half base times height.
Half base times height. And what is our base? We have half. Let's write down the half first. We have half. What is our base?
4, sir.
Our base is 4. And our height is what? What's our height?
Don't know what your answer.
6.
No.
It's a, I can't tell.
Our base. All right. So our base is 4. What is our height?
Sir, I didn't get that one. A choke was passing.
Right. So our base is 4. And what's our height?
Yes, sir.
Our height would go from here to down here, right? That's the total height. So what is this distance here?
12.
12, close.
Abby, Abby, please.
11, sir.
Right, 11. Perfect. So, get your calculators now. Get the calculators. What is the value for this? 4 times 11 is how much?
44.
Right, so it
Sir,
is
answer 22.
right. The answer is 22. So are
2,
we all
sir.
seeing that?
Yes, sir.
Yes, sir.
All right, so 22 bananas, 22 dumplings.
22. Sir, no.
Meters squared, right?
Meter square, sir.
Right, meters
But sir,
squared.
I'm not in a meter today, sir. So I go
Yes.
put meter
Well,
square.
just assume that this is meters. Okay?
Okay.
Yeah. All right, so we're at figure 2. Figure 2 is a triangle, right? Figure 2.
No,
What is
sir,
figure
figure 2
2?
is a rectangle.
Right,
Close to
so figure
Rectangle.
2 is a rectangle. So, what is the formula for rectangle again? Let's go back. Of rectangle is what?
Area times
Sir,
height.
I
So
times width, sir.
With
height.
times height.
With
Yeah, so
times
width
height.
times height. Right. So let's go back now. So we have width times height, right? Width times height. So what is our width?
12, sir.
Our width is 12 and our height is
6.
I think
6.
6, sir.
right. So what is our area for figure 2?
12 times 6. 6, 12.
This is our area for this.
72, sir.
Right, so 72 bananas.
72, sir.
The 72 bananas, right? Or 72
Sir,
monkeys?
say
Yes, sir.
72 apples, sir. 72 apple better, sir.
No. 70, all right, 72 meters per square, right? Just tell me the unit.
Yeah, yeah.
Yes.
That's the point
Yes,
I'm
sir.
trying to make. All right, don't be a
Yes.
smart guy. All right, and figure 3. Figure 3 is a triangle, right?
No, sir.
Figure 3 is a what?
It look like a square.
No. Check it again.
It cut off right there, so. And come
Yeah.
here, so.
It is. It goes sideways.
This look like a square?
It come now and then go back side here.
This
So
is a
now a
square?
square that.
No.
Yes,
Look on your
Yes,
sir.
sir.
sides.
Yes, sir.
Look on your sides. Is this a square? Try again.
Sir, that is a square.
No, it's not. It
A
looks like a
square,
square,
man.
but it's not a square.
Sir,
All right,
it's a rectangle, sir. It's a rectangle.
it's a rectangle. Who said that?
Because a square, all sides are equal, and if the side is 5 and the bottom side is 4, it is not
Right,
equal.
right. So thank you so much. So we have this side to be 5 and this side to be 4. These are two different sides. So it has to be a rectangle, right?
Judge Andrade said that, sir.
All right. All right, so rectangle. Rectangle. I'm sorry, the computer is moving slow. So that's why you're not seeing it perfectly. But let me see if I can try again. Computer is moving on to so correct. That's right. Rectangle. Right, it's on the other slide still. Right, if you go on the other slide, you see it. So rectangle, and our formula for rectangle again is How do we calculate the formula for rectangle again?
So base times height times. No, sir.
All right?
Sir, it's the width times height, sir.
Width times height times height, right? Now, what is
Yes,
our
sir.
width again? What is our width?
4, sir.
Our width is 4, and our height is
5, sir.
5. All right. So our area would be
20, sir.
20, right? We are 20 what? 20 apples.
Meter square, sir.
20 meters square, sir.
All right. Now, how do we find the area for each of these? Figure 1, figure 2, and figure 3. How do we find the total area now?
Again, sir.
Sir, go add it up, sir.
Sir, we add all of them, sir.
So to find the total area of the irregular shape, we simply add them up, right?
Yes,
So
sir.
that would be, let's start from figure 1. Total area. Total. I'm really sorry about this. Right, the internet. Sorry, my laptop is moving slow. So it'll be figure 1 is 22, right? And what is figure 2?
Sir, figure 2 is 72.
72.
Sir, the answer is 114, sir.
All right, let's slow down for a second, right? All right, and we said that the answer is 5,000.
114
All right, 114 what?
meters square.
Meter square.
All right, 100 and, oh my God. 114 meters squared. Right, squared. Yeah. So that's it for today. We completed a lot. Any questions before we go?
No,
No,
sir.
sir.
All right. So the same thing is over
Let
here.
me
This is a little bit neater. All right. You can see that it's a little bit neater, but it's essentially the same thing that we just did. Half base times height, length times width, and length times width again, and the total.
Sir, may I
area
take
of triangle.
computer, sir?
All right. You can do that.
Sir, may I
quickly.
take comp?
Yeah, man. So I'm gonna finish. Remember that this will be posted. All right, guys. So not everyone has to take a picture.
Sir, I'm finished.
All right. So I'm going to stop sharing. Are we good now?
Yes, sir.
All right. I'm going to stop sharing now. All right. So we're out of time. Jamie Lee is late. Or probably was here
Sir,
before.
tell her that class is finished.
All right. So all the best, everyone. All right.
Bye, sir.
All right,
Yes,
take
sir.
care.
Have a good day, sir.
Thank you so much. Same to you. Jamie Lee's not here. I hear a question.
Oh, wow. Hi, sir.
All right. Yes, the class is finished. All right. But the link for the recording will post it.
Oh,
All right. All the best, everyone.
you